Okay, let me, I'll introduce. Good. All right. Thank you, sir, for giving me the thumbs up. All right. Our next talk is called When It Rains, It Pours. It's about connected devices. I cannot hear enough talks about connected devices, honestly. Seriously. I mean, I'm being serious, not sarcastic, because it's a mess, you know. And I love hearing about how, well, I'm not going to steal your thunder.
Go for it.
This is, I'm excited to hear this.
I'm glad there's a passionate person in the audience.
So Sam is a senior security consultant with a passion for connected devices and breaking home automation. I added that in there for you. So, Sam Granger, thank you, sir.
Thank you. All right. Can everyone hear me okay? Okay, that's better. Good afternoon. Thanks for coming to my presentation titled When It Rains, It Pours. The purpose of this presentation is to take you through the journey that I went through to uncover several critical security vulnerabilities in a popular irrigation system using basic pen testing tools and techniques. This presentation also serves as the final stage of the responsible disclosure process. So first, a disclaimer. The views presented in this document are my own, and they do not represent the position of my employer. And secondly, all the testing was performed on my own personal device, exclusively on my own device, or using the information generated from my own device. So let's look at the agenda. First, I'll talk a little bit about myself. Then I'll talk about what was compromised, how it was compromised, the methods used to compromise that device, some other stuff, and then how it profited. So a little bit about me. My name is Sam Granger. I am a security researcher, as you got told. I have a passion for connected devices and home automation. In my spare time, I've built several devices to turn non-IoT devices into more IoT devices, I guess. This has mostly involved the use of radio with on-off keying and the likes of an ESP8266 chip to give things Wi-Fi. And for those of you who don't know, the ESP8266 is like an Arduino with Wi-Fi built in. So let's talk about what was compromised. The device is known as a rain machine built by a company called Green Electronics. And per their website, the rain machine empowers the gardener with the most weather-aware, iOS and Android-capable multi-valve irrigation device on the market. Now, to most people, this means that this device will go out to the internet, it will grab some weather data, it will download it, and it will make some intelligent decisions on how to water your garden. At the time of writing this presentation, there were two models out on the market. The one in the back there is known as the Mini 8, and the one in the front is the Touch HD, which comes in a 12 or a 16 valve model. The Touch HD in the front runs an Android Jelly Bean, and the Mini 8 in the back runs OpenWRT. The main application is written in Python, except for one component, which is the Cloud Connection daemon, which is a compiled binary. And one of the features that really attracted me to this device in particular was how developer-friendly it is. They have a strong community of garden and tech enthusiasts, and the company themselves are very promoting of tinkering with their device through the use of their API and their SDK. Another nifty feature is you get SSH right out of the box, so that's really cool. And it is, of course, cloud-enabled. This screenshot here is a picture of the cloud interface. You enter your email address and your password, and you get into your device. This is what you're presented with. This is the dashboard. You have things like the zones down the bottom here, which control if you want to turn your sprinklers on and off. You have a program, some weather information, and a nice little graph in the top left corner which shows you how much water you've saved because you're using a smart irrigation device. This works in both the cloud, and there's also a local instance of it you can just check on your local network. This here is the REST API test page. This gives you access to the REST commands. You can use this to test out the various commands, and it also has the parameters so you know what's required to actually make these different calls. So method one, I called this generating your own credentials. So as I alluded to before, getting on the box with SSH is, well, a feature. So once I was in the machine, I found the interesting folder called Rain Machine App, and this is where the bulk of the functionality lived. So I copied this down to my computer for easier analysis, and I don't know if you can see from there, but the files are stored in this PYC format. And the PYC format is a compiled bytecode format. And in this current state, I wouldn't be able to open these files in a text editor and read them that easily. Easily being the key word. But it doesn't matter. The first test I'm going to do anyway is just a simple string search. So, bingo, FTPayday. I found some hard-coded FTP credentials in the RM dialog upload file. This particular function is used to upload diagnostic logs to a centralized server, say you're having issues with the device or something like that. But the host and the username were in clear text, and the password was hex encoded, which is not really any sort of encoding at all. But you could just decode it with the likes of Burp Suite or anything online. So what was the impact? Well, I would later find out that the credentials were shared liberally amongst all of the RAIN machine devices, and it turns out that a misconfiguration in the FTP server not only allowed you to download your own logs, but also the logs of other users. It turns out there was about 3,000 odd unique devices that had uploaded logs to the server. So what was in there? Well, I started monitoring my own traffic from my device to see what it was uploading during this process. And along with some system and application logs, one thing that really caught my eye was it was uploading certain databases, and these were the SQLite databases. One of them that really caught my eye was the RAIN machine settings database. And this is what it had in it. It had a geographical location. Obviously, you need a point on a location to do good weather forecasting. Had the email address of the user registered with the cloud. It had local session tokens, and it had, of course, the password hash. So at this point I was hooked. I was like, this is really cool. I want to see what this device really has to offer. But I had a problem. I was stuck with these PYC files and I needed to get them back into a readable format. So this is where Uncompile 6 comes in. Using Uncompile 6 I was able to convert the PYC files back into their Python form, and I started looking around for interesting functions. And this is where I came across one called the TOTP. Now the TOTP stands for time-based one-time password. And this particular code is a 6-digit code that you would give the likes of an irrigation installer or a contractor to give them access to your device without having to give them your real password. In this way, you'd also have to give them your email address as well so they could log in through the cloud. Now, there's only one account on the RAIN machine, and it is the administrator account. So giving someone the TOTP is actually as good as giving them administration control to your device. There is a caveat, though. You have a 6-hour window that you can use this TOTP in, which to most people is probably plenty of time. So I pulled apart the function, and this is up on the screen here, and I noticed that the TOTP used the password to generate this code. Except when I started actually tracing through the different calls it was making, I realized that it wasn't actually the password used to generate this code, but in fact the password hash. And this is shown in the third image down the bottom, where you can see it's making a select statement to the SQLite database. So let's just recap for a second. I've learned that I can access thousands of these password hashes through this FTP server. I can also get the corresponding email addresses associated with those password hashes. I have the source code to generate my own password equivalent, and I only need that password hash to generate that equivalent. So I'm in. In the top there, this is me creating my own TOTP function, and I can give it a hash, and it will generate me a one-time code. And for comparison, I've shown the same code that you get if you make the request to the RAIN machine device itself. So this definitely did work, and it did work through the cloud as well. So this was my first CVE. This is CVE 2018-6011, the time-based one-time password function in the application logic of the RAIN machine uses the administrator password hash to generate a 6-digit passcode that can be used for remote and local access, aka the use of a password hash instead of a password for authentication issue. This is exploitable by someone that can get hold of that hash value somehow. So it's really great to have access to thousands of RAIN machine devices. You could probably cause some mischief, flood some lawns, make some water bills go up. Great. But really, it doesn't give you access to the local network, and that's what we're really interested in. So I started looking around the UI for injection opportunities. And I came across this really neat function called the add new weather data source. Now, I'll back up a little bit. What makes an irrigation system or a smart irrigation system so great is the ability that it has to go out to the internet and look up weather data information, whether it's historical or forecast, parse that information, and then turn it into something useful that it can make decisions on how to water your garden with. Now, There's certain situations where maybe the data you have isn't supported by the RAIN machine yet. For example, if you own your own personal weather station, or maybe you just live in a location that doesn't have support yet. In these instances, the RAIN machine team was really generous, and they give you the ability to upload your own custom weather data parser. And this is in the form of a Python script. Now, I don't know about you, but anywhere I see that you can upload your own Python script, alarm bells start ringing. So today's forecast, cloudy with a chance of code execution. I grabbed the most simple reverse Python shell that you could probably find on the internet, and even though it says there's an error in uploading it, as you can see, I was clearly able to get shell out of it. So there you go, CVE 2018-6012. The weather service feature of the Green Electronics RAIN machine allows an attacker to inject arbitrary Python code via the add new weather data source upload function. So there you have it. You got your irrigation botnet army to do whatever you want with. But why stop there? Let's see how else we can attack this thing. Let's look at some web attacks. This device has self-stored cross-site scripting. Due to a lack of input sanitization combined with a lack of appropriate response headers, such as specifying the content type as JSON, you can post a self-stored cross-site script. In this particular instance, I've created a new program, and I have changed the field name to not a good name, but that of a malicious script. Alert 1 seemed like a good name to me. And I was able to trip this by then looking up that program that I just created. There's some other vulnerable locations as well, like the zone creation, pretty much the same thing. And also this diagnostic log page. If you modify the email address that's registered with the cloud service, you can also trip a cross-site scripting issue. So this was CVE 2018-6906, a persistent cross-site scripting vulnerability in the RAIN machine web application allows an attacker to inject arbitrary JavaScript via the REST API. We also have cross-site request forgery. In this particular instance, I would make some super attractive looking link that I would convince someone to click on. This would return some JavaScript, which would in turn make a post request to actually upload a self-cross-site scripting. In this case, I would do it via the email address. I'd modify the email address of the user, and then I would have that JavaScript on the malicious page to redirect to the diagnostic log page, which would then trip the cross-site scripting bug. In this particular instance, I've had that cross-site scripting then make a call to get the TOTP function, which is the grand code that I'm always after, and also pull out the email address of the user, and this sends it to the attacking server via a GET request. So in this way, I'm able to steal credentials and then log back into the device through the web portal, through the cloud. This is CVE 2018-6907, a cross-site request forgery vulnerability in the RAIN machine web application allows an attacker to control the RAIN machine device via the REST API. We also have clickjacking. In this particular instance, the setup is actually very similar to before, so you would use possibly cross-site request forgery to upload a self-cross-site scripting bug. And rather than doing a redirect to get the cross-site scripting to get executed, you might try to convince the user to click on a fancy-looking button like click to win, and it's got a hidden iframe, which would essentially trip that cross-site scripting. Obviously, the previous method is way, way more effective. But this does have the advantage in that you can take advantage of some of the existing AJAX functions used in the REST API test page to trip the cross-site scripting issue in just a slightly different way. There are some other use cases for clickjacking. You might want to try to turn on SSH, or maybe you're just a pain in the ass and you just want to turn on their sprinklers without them knowing about it. So this was CVE 2018-6909. A missing X-frame options header in the RAIN machine web application could be used by a remote attacker for clickjacking, as demonstrated by triggering an API page request. So what about some sort of authentication bypass? That might be interesting. I started getting really curious about how this whole cloud service worked, and I learned that there is this cloud connection daemon which sits in the middle of the RAIN machine web application and the cloud servers. And it acts as a very, very simple proxy. It would basically pass the information virtually unmodified to the device. So I decided to fire up SSL split and have a look at the traffic, and I noticed that it was mostly HTTP, but it had a few extra bytes at the start, which indicated the message type and the message length. Now, the only impact this has is that it just made it a little bit harder to sniff this traffic because Some of the proxies out there that expect pure HTTP wouldn't work with this situation, but this is where SSL split would shine. And so I got curious. I was starting to watch the traffic, and before I'd even interacted with my device through the cloud, I noticed that the cloud service was making requests to the RAIN machine, requesting information that you'd normally need to be an authenticated user to get this information out. And the funny thing was, the RAIN machine was honoring this, and it just treated the cloud service like it was authenticated and passed back that information. It was giving it things like the version information, the machine time, and even information about the programs that were on that device. So I was really curious. How come this cloud service can act like an authenticated user before it's even gone through an authentication process? So I took the SSL split logs and I converted them to a Wireshark format because looking at red and blue is slightly easier than looking at black and white in this case. And I noticed that the requests made from the cloud service were really, really simple in nature, but one thing they did have in common is they always specified the host header as localhost. The only time I didn't see this was when I actually tried to log into the device itself through the cloud portal. And in this instance, the host header changed to that of the internal IP address of the cloud server, and it was the only time I'd ever catch this 401 unauthorized error. Obviously, I botched my password here, and that's why I'm unauthorized. So I looked around the code, and I found out that when the device checks to see if the user is authenticated, there's a little caveat to the side, and it checks, is the client local? And it turns out the way you're local is if you can specify the host header as localhost. So was it really that simple? Well, yeah, it actually was. So I put together a curl request, very, very simple, to request the TOTP, which is the one-time code to give me access to everything, as an unauthenticated user, and I specified the header as localhost. And at first this didn't work, and I thought, why? But I tried playing around with it a little bit, and I specified a port number as well, and suddenly the attack would work, and so I could bypass any sort of authentication. So this was CVE 2018-6908. An authentication bypass vulnerability exists in the RAIN machine web application, allowing an unauthenticated attacker to perform an authenticated action on the device via the localhost port value in the HTTP host header, as demonstrated by retrieving credentials. But surely this is something the developers thought about. I mean, they actually added it as a feature to the device. So having this as being abused by an attacker is maybe something that came to their mind. And truthfully, they did. They thought about this as an issue. But design and execution are not always aligned. There is a service that sits in front of the web application, which is the light HTTP daemon service, which is basically a reverse proxy to the web application. And what this does is it takes the host header and it will replace it with the word removed. Except that's not quite how it works. What actually happens in reality is it doesn't replace it with the word removed, it appends the word removed to that header. And so you get a situation like we have down the bottom here, where you have host header, whatever I specified, comma, removed. So what impact does this have on the application? Well, digging a little deeper, I learned that the way that the device is parsing headers, it's performing a split on the colon character. Now, the first part of that split is known as a key, and that becomes the header. So in this case, it would be the host header. And the second part of that split becomes the value, in this case, localhost. Everything else beyond that point, any other splits that have occurred, I've forgotten about. So if we specify localhost port number, essentially we're just specifying localhost. And so I've demonstrated this on the right. This is the information that the application would see, and then after it's been processed, this is what the final result is. And so in this way, we have effectively we've used the localhost bypass authentication feature. So I was curious, could this work through the cloud? Well, for it to work through the cloud, two conditions need to be in place. The cloud service would have to authenticate directly to the RAIN machine device itself. This would mean that whatever password I typed into that cloud portal would be presented to the RAIN machine, and the RAIN machine would decide whether I should be authenticated or not. And the second piece is that I would need to be able to control the host headers, or any of the headers actually, all the HTTP headers, and they would have to be preserved all the way to the device. Well, of those two things, the first one is actually how it works. When I try to authenticate, it's the device making the decision. But unfortunately, the second part doesn't. Any of the headers I specified in the cloud portal wouldn't go all the way to the device. So no, we cannot bypass the authentication through the cloud. But wait, did I mention mobile? The mobile service works in a little bit of a different way. The mobile service will call a subdomain appropriately named proxy finder. And this will use my email address to look up the unique ID of my rain machine device. Once it has this unique ID, it will make a call to the API endpoint using my unique ID in the URL. In this way, it creates a tunnel where I am effectively communicating directly to the device. This means that I can control not only the body of the HTTP request, but all the headers as well. So here's my proof of concept. In this first screenshot, I'm calling the proxy finder service with my email address, and it is returning all the information I need to know about my rain machine device, including that unique ID. I then take that unique ID and I contact the API endpoint with the unique ID specified in that red location in the second screenshot, and I call the TOTP function to see if I can get that code back. And you can see I've specified the host header as localhost. In this particular instance, I don't have to deal with the light HTTP daemon, so I don't have to worry about any of these extra colons to try trick it into letting me in. And the third screenshot here is just a way of me combining the first two to make it look really easy, and you can just give it an email address and you get some information back. So what happened next? Well, I disclosed my findings to the rain machine team, and they responded to me within 15 minutes acknowledging that what I had found was a really serious security issue. They immediately pushed out patches to resolve the issues associated with the cloud services and the FTP servers to block those off from being attacked. And they subsequently pushed out some firmware updates to resolve some of the other bugs. Overall, I was really impressed with how this company responded, and you could tell that they took the security of their customers exceptionally seriously. So where was the profit? Well, I actually got a free unit out of it. They were nice enough to send me a, thank you, a Touch HD, which was an upgrade from my Mini 8, so I was very pleased with this. And it is with this device that I will demonstrate some of the attacks I've talked about during this presentation. As I've mentioned, the cloud services have been shut off for these attacks, so I can't attack it this way, but I can demonstrate some of the attacks via the cross-site request forgery and cross-site scripting attacks. So here's my attack chain. The user will log into the device will return a session cookie. The user will click on a malicious link that I made super attractive somehow, and this will return some malicious JavaScript on a web page. And this JavaScript will use WebRTCs to identify the local IP address of that device. It will then scan the subnet looking for rain machine devices it can attack. And I will let you know this, there is one unauthenticated call that you can make to the rain machine which will clearly identify it as a rain machine device. Once it finds a rain machine device it can attack, it will post a cross-site request forgery to load up some cross-site scripting. This is through the program. It will then redirect to trip that cross-site scripting attack, and then that cross-site scripting attack will go and fetch some more malicious JavaScript because I couldn't fit all this in one line. And once that JavaScript has been returned, it will do a few things. It will upload a Python script so that I can backdoor this device. It will also create a WebSockets connection so that it can get feedback about what's happening. There is absolutely no practical reason why you'd do this, unless you're taunting the user. But for the purpose of the demo, it makes it really easy to show what's happening in the back end. Once the Python script has fetched once Python script is uploaded, it will fetch a malicious shell script, because shell script was a little bit easier to write in this case. Don't need to go into why. And then that shell script will extract some data, send it to the attacker, it will grab some new tools, it will then look for other vulnerable rain machine devices that can use the host header bypass feature. And if it finds one with an active zone on it, it will turn on a sprinkler. And then it will install some malware and it will feed all this information back via WebSockets to the user. So let's hope this works. Can we get a bit of sound as well? Is that working? Oh, no, that's disgusting. Let's do it like this. Don't worry, I came prepared. Can we get sound with this by any chance? Oh no. That's right. So this is its log. It's basically cross-site script attack. This is a WebSocket. It's extracting data from the device. It's now searching for other rain machine devices that are vulnerable to this host header bypass. If it finds one, it checks the sprinkler zone to see if anything's active. Find zone 4. Turn on the sprinkler. It's not done yet. Decides to install a game. That's fantastic. Go check your rain machine device. Shit. I'm not going to do that. So unfortunately the doom sound that goes with it isn't here, but you can imagine how it sounds. It was good. I'm not very good at this game when I play it on this device either. It's about as far as I got. Alright, thanks. Back to our presentation. So yeah, it plays... Where is it? Let's get this back up there. Oh no. Yeah, we can do it like this. I bet you it'll play now. So yeah, it plays Doom. For those that are interested, this is the PR Boom for Android package. This has been modified to fit the rain machine device. It has a slightly different file structure, so I had to mess around with that and recompile it. It was a right pain. So what can you take away from this presentation? Well, maybe it's stuff you already know, but I'll reiterate it anyway. Connected devices are often quick to market with security being overlooked. Connected devices are a window into our homes, our offices, and our campuses. Connected devices have been hacked before and they will be hacked again. And the basic techniques are still profitable. So I'll now take any questions. And there's my contact information. It's all good. All right. I haven't seen anyone, so thank you guys.